In this video, we are going to review how we graph quadratic functions, sorry. This is a quadratic function, and quadratic functions like this can be extracted, can be found in real-life problems. For instance, this one can be extracted from the context of a problem that I'm going to tell you now. Imagine that this is a function that describes the movement of a rubber bullet that has been shot from the top of a building. Okay? We shoot a rubber bullet with one of those guns that shoot rubber bullets, and it follows this equation, this function, in which x is going to be the time since we shoot, and the y, the time is given in seconds, and the y is going to be the height given in meters, the height from the ground. Okay, so all the numbers here in this function have a physical meaning. For instance, this -5 is approximately half of the gravity. Why half? Because that's the way, that's the formula for a decelerating movement. 1/2 of the gravity. Gravity is 9.8, so 1/2 is 4.9. But to make it easier, I have rounded to 5. And -5, it is negative because gravity pulls down. Okay, so that's why it carries a negative sign. And 20, this is the speed with which we shoot the bullet, the starting speed. 20 meters per second. The units are always the units of the y and the x, so the speed is given in meters per second. This 9 has a meaning as well, but I'm not going to tell you now. Probably you remember the meaning of this 9 because we have done this problem in the classroom before, but it's one of the questions that we are going to answer later, so I'm not going to tell you now. So first we are going to graph this function. You know that the graph of a quadratic function is a curve that we call parabola. It has a special shape. And to remember how to do that, we are gonna put here the things that we have to find. We have to find the vertex and the axis hits, the y-intercept, and the x-intercept. Okay, so let's start with the vertex. Remember the formula to find the vertex. To find the x-coordinate of the vertex, we apply a formula which is minus b divided by 2a. Okay, so b, remember, was the coefficient of the x in the parabola, so this would be minus 20 divided by 2a, and a was the coefficient of the x squared, so 2a, it would be 2 times -5. So we have minus 20 divided by -20 divided by -10, so that it becomes positive, and that is 2. As this is the x coordinate and the x is time, so this is 2 seconds. And the y coordinate of the vertex, which will be the height, remember that once we get the x, we replace that number here and get the y. So -5 times 2, I don't need the parentheses because 2 is positive, so 5 times 2 plus 2 squared, x squared, minus 5 times 2 squared, x squared, so 2 squared, plus 20 times 2 plus 9. Okay? So let's do the calculations here. Minus 5 times 4, so it's negative 20, plus 20 times 2, which is 40, plus 9, so minus 20 plus 40, that's gonna be plus 20 plus 9, that's 29. And this is the y is height in meters, so 29 meters. Okay, so we already have the vertex, which is 2, 29. Okay, and now we go for the axis, the axis hits. We go for the axis hits. The axis hits, first the y intercept. For the y-intercept we make x equals 0. So what do we get here? Y equals minus 5 times, we make the x 0. So we make the x 0, this becomes 0, this becomes 0, and we get only 9. So the y is 9, and the point is 0, 9. Okay? And for the x-intercept, we have to solve this equation equal to 0. So 0 equals minus 5x squared plus 20x plus 9. To solve that, we apply the formula minus b minus 20 plus minus square root of 20 squared minus 4 times a, so minus 5 times c in this case is 9. Okay, so it will be divided by 2a, 2 times negative 5. Okay, and I think I'm gonna change the marker because it's running out of ink. So let's do the calculations. Minus 20 plus minus 20 squared, that's 400. Minus and minus is plus, and that is 20, and 20 times 9, it will be plus 180 divided by minus 10. So 400 plus 180 will be 580. 580. And here we have two solutions. It will be minus 20 plus the square root of 580 divided by negative 10, and minus 20 minus the square root of 580 divided by negative 10. Okay, you can stop the video here and do the calculation yourselves. I'll tell you in a second. So one solution will be minus 0.41 seconds, because we are talking about x, and x, remember, was, I erased it, but x was the time, so seconds, and 4.41 seconds. So those are the x-intercept. The y is 0 and one is 0.41 and the other is 4.41 0. Okay, so now with this we have all the information to graph the parabola, to graph the function. Okay, and to graph the function I'm gonna draw the axis, the coordinate axis. I'm not using the negative part of this axis, so I'm gonna put the origin here, and let's see. Here for the vertical axis I need to go up to 29, so I'm gonna make it in 5 like this. 5, 10, 15, these, remember these are meters. 15, 20, 25 and 30. With that I have enough. On the other axis, though, these are the seconds, this is the x-axis, I go, the highest number is 4.41, so it is enough if I use this. 1, 2, 3, 4, 5, and that should be enough. If you want the negative, it would be here, -1, and this would be -5. And now let's graph the points. First the vertex, 229, so 229, it would be here. The axis hits, 0, 9, 0, 9, it would be here. Minus 0.41, 0.41, it would be around here. 0.41 negative point. And 4.41, 4.41 around here, 4.41. And now we are going to draw the graph. Here. Like this. Okay, I hope you see that properly. Okay, so now remember the points. This is 0, 9, and this is 229. Okay, and this, if you want to put the other coordinates, this is 4.410 and -0.41 and -0.41 0 as well. Okay, so this is the graph, and now we are going to answer some questions about this specific case. Remember, this was a function describing the movement of a rubber bullet that is shot upwards from the top of a building. So the first question is going to be how tall was the building from which we shoot the rubber bullet. So, and here is the answer, 9 meters tall. We shoot from here in the first place, okay? The bullet is shot from here, okay? So that was the meaning that I didn't want to tell you before, the meaning of this number. So remember, half of the gravity, the speed with which the bullet is shot in the first place, and the tall of the height of the building from which we shoot the bullet. Okay, so what is the highest point of that bullet and when is it reached? The highest point that you can see here is 29 meters. That's the highest height, and is reached in 2 seconds. 2 seconds after the bullet is shot. Okay? How long does it take the bullet to fall down, to hit the ground? Here is the answer, 4.41 seconds. Okay? This part of the graph has no meaning in this, has no real meaning, no physical meaning in this problem, but mathematically it's a part that exists, but in this problem it has no real meaning. The real meaning starts here when we shoot the bullet. Okay, and now I'm gonna make one more question. For instance, how long is the bullet over 20 meters? Is the bullet higher than 20 meters? So I'm gonna draw a line here in the 20 meters, and I want to know how long is the bullet over that height. So quite easy. Just find this number and we get it. Okay, find this number and this number. If I could trust the drawing, the graph, I could estimate that this is more or less a little bit less than 1, and this is around 3.6 or something like that, but I cannot trust this drawing because it's not square paper. I've done it by hand, so it's not trustworthy. But I can do something. I can calculate that by equating this part of the function, so the function equating that to 20, and then I will find this point and this point. And if I solve that equation, so I'm going to equate this equal to 20. Minus 5x squared plus 20x plus 9 equals 20. So let's solve this equation, this quadratic equation, and we will get these two values for the x. The values of the x that make this equation true are this and this. So I have the second in which the bullet goes over 20 meters and the second in which the bullet goes down. It passes 20 meters down. So to solve this, remember we need a 0 here, so we are going to move this 20 over here. So it would be minus 5x squared plus 20x plus 9 minus 20 equals 0. Let's do this 9 minus 20, and that would be minus 5x squared plus 20x minus 11 equals 0, and let's solve this equation. Let's solve that equation. Let's make room here, and x equals minus b, so sorry, this is 20, minus 20 plus minus square root of b squared, so 20 squared, which will be 400, the same as before, minus, I'm gonna do it now, the calculations, minus 4 times a and times c, so minus 4 times 5 times negative 5, it will be plus 20 times negative 11, it would be this minus, it makes the sign minus again, minus 220 divided by 2a, 2 times negative 5, so that would be negative 10. Okay, and now solve this equation. It's almost solved. Just do the calculations. 400 minus 220, take the square root, and then minus 20 plus that square root divided by minus 10 gives you one solution, and minus 20 minus that square root divided by negative 10 gives you the other solution. Stop the video here, do the calculations, and check if they are right. 0.66 and 3.34. 0.66, of course, seconds, because we are talking about 0.66 seconds, because we are talking about the x, which was time, and 3. I don't remember, 3.34 seconds. So we already know this point here was 3 point, I use a comma as we do in Spanish, 34 seconds, and this point was 0.66 seconds. Okay, and now minus 3.34 minus 0.66 and that would be the time that it is over this height, over 20 meters. If you minus, it's 2.68 seconds. 2.68 seconds is the time the bullet takes to make this part of the curve, to cover this part of the curve. Okay?